Good afternoon, everyone. Okay, so hi. So my name is Krupakar Annam. I lead engineering at Aviz Networks, and with me I have my AI projects lead, Kuldip Patel. He works with me. So yeah, thank you. Okay, before even jumping into the slides, right? Just want to give some, some pitch about AI, right? So I think we are here today talking about AI, all this. We have been thinking it's a hype and all that, but I think it has reinvented and it is a reality now, right? And the AI hunger for data is more. It's asking for more data everywhere, right? And the most of all, the generative AI is the hunger monster basically, right? But it's a good monster, right? That's where the business is. So I think AI is going to be the business driver for all the data centers going forward, right? Because we have seen so many investments pouring in from everywhere, right? It's going to stay. That's the reality, right? So having said that, there are so many challenges, right? So are we ready? I mean, as a community, as a SONiC community, we are like 2,000 plus folks here looking at, trying to bring in SONiC everywhere, with the open source, challenges, everything. Are we ready? Answer is probably yes, right? But what happens is, sometimes years of innovation happens in weeks of time, right? So I think AI is at that stage, right? So it's going to change very, very fast, right? As a community, are we ready to catch up with that fast-paced, innovation? So that's the open question. So with that question, I'll hand over it to Kuldip. He will take us through some of the, let me just, yeah. So we'll just try to deep dive into the, what drives the network size, right? What is how the landscape is going to change, okay? And then what are the challenges that we see, and how can we solve it, and what are the callouts for SONiC community to address those challenges. So this is what we want to cover. Over to you, Kuldip.
Yeah.
Just,
Thank you, Krupa. Yeah, hi everyone. Myself, Kuldip. I represent here the Aviz Networks. Ashay, thank you for give a knock on the door that post lunch at least be awake. It's not fair because the morning presentation, I think people have been having more energy compared to the post lunch sessions. But I think I can see the crowd strength compared to last year. I think I can see double the strength right now. So thank you for coming here, and thank you Microsoft team for hosting us. Yeah, before we jump into the AI, right? Today morning when I was scrolling my cell phone and I was checking something on Wikipedia, the first pop-up came that give us a money. We are not, I think, sold yet. Why? Because that is the source of information. Maybe if we go down the line and look at 5 or 6 years back, if anybody want to search anything, there are some information base exist through which you can search and find the information. But now that doesn't mean it is obsolete. It has its own base, right? Now if anybody who wants to create something on top of it, or what we call it today, it's a Gen AI, right? Somebody has to crawl the data. The data is today, if there any event happens at this moment, the next moment or probably within an hour of time, that guy would have been updated the data. So let's give a credit to that network, but on top of it now our habit changes. Now I don't go to the Wikipedia and look for that information. Maybe now recently in WhatsApp update you have AI there, you can go and ask it, it gives the same information, right? So that doesn't mean that we are discrediting the older way or legacy ways of getting that information, but we now find a convenient way to extract all this information. But those things comes by doing something. So AI, artificial intelligence, it's not new word for all of us, but probably generative AI, it is something altogether a new paradigm in this era, I would say. So having said that, what we wanted to cover today is, let's look at the various aspects of it. Maybe some of the things I think Saurabh already had covered up in his presentation too, and in the initial note, Microsoft folks already covered up some of the topics. But what I would like to try to address now is, if it is generative AI, which is knocking our door already, as Krupa said, are we ready first of all, and are we ready with the SONiC? That is the second question, right? and then we will look at some of the aspects that where we are in terms of this with the community SONiC. Okay, so with that I will begin my presentation here. Okay, so this deck we picked it up from Meta's presentation about the networking at the scale. Recently they have represented. If you look at the last row where they trained the Llama 2 model with 70 billion parameters with 2T data set size with 800 zettaflops computation power with a 100 2K GPUs, it took close to 1.7 million GPU hours per month to train, right. Now here the key whatever highlighted there is InfiniBand is being used. Now if you look at the third row there, same model they tried to train it with 34 billion parameters with the equal data set size with the less amount of computation power, same set of GPUs, number of GPUs, but if you look at the GPU hours it took per month is 1 million hours. So what I am trying to showcase over here is not to credit or discredit anything or not to compare these rows, but this is a good sign for us. I think one of us today, I think Amir only took it, right, Ethernet. So this is what it is. So it's not about what is right versus what is wrong. Practically economically viable solutions are the one people will move on to. So that's the point there. So if we compare by number, okay, we reduce the parameter size but we reduce the computation size over there and you got almost equal results over there. So that's a key takeaway from these slides, right. Now there are various results also they published it, but I am not going in detail in that, but what I wanted to highlight from this slide is these 2 points. So this is a positive sign as in community in the sense SONiC community. No matter whether we are really directly contributing or not, but that's a way out to find a economically viable solution out of it, right. Moving on to the next slide. Now the first slide put a question on us that now this when we look at those numbers are very huge in terms of data. So our network size, it depends on what, okay. If you look at traditional where in the last few decades our data centers deployment strategy used to be like more of an server centric, where our goal was to efficiently communicate between 2 servers where it can efficiently transfer east to west or north to south sort of traffic. But now in this era when we are talking about Gen AI, right, so it took a center stage. You need to change your deployment strategies totally from server centric to GPU centric. So here I am taking an example where I have shown here 2 DGX servers connected with which each of it has 8 GPUs interconnected with any switch, and the topology here being used is probably 3-stage close you can say. But what has changed here? This is just in simple, right. This many amount of handful GPUs are not enough to train any large LLM models, because that requires a huge amount of number of GPUs. So what you need to do, your topology will become like a dragonfly or fat tree, okay. So this changes your traditional way of your data centers being deployed, right. It has to change and it has to evolve. So from the networking perspective, some of the parameters which were probably decade old, or that mindset has to change and we need to address that, okay. Moving on to the another slide. So if we look at last 2 slides, the question is how this thing is different than the traditional network what we have. So as per me, there are 3 characteristics in which we can divide this. One of them is workload types, second thing is your communicating or connecting techniques or the algorithms, and how efficiently you can run those algorithms using what infra, okay. So if you look at the workload types, I think some of the topics I have covered here, I am just repeating and quickly iterating through. Training, fine tuning, inferencing, right. So during a training phase, it is more of an memory intensive or probably you can say computing intensive job. Now when we look at the fine tuning phase or that workload type, right, it becomes little less aggressive compared to your training phase. And when we look at the inferencing phase, that's where you need a very low latency and prompt network support in order to make it more interactive towards the end user, right. There are various communicating or connecting or algorithms are available through which people do train their AI models or their framework, okay. But the main problem comes is no matter which method or connecting techniques you come up with, you have to efficiently execute it in order to get the better throughput out of it. So a lot of optimization needs to be done in terms of running and using these frameworks too. So these are the three pillars of how these are the three pillars how your actual Gen AI networks differ from your traditional networks. Okay. Now I will take one of the connecting techniques here, or one of the algorithm here, which is all reduce. This is the traditional, I think whoever is working on this area probably aware of this model for sure. Here what happens is, any GPU who is coming up with the results, or in technical terms what we call it as a gradient, right, it tries to communicate with other GPU and share that gradient with the other GPU. So what it means is, each GPU tries to communicate with other GPU, that means one to many or many to one. So this looks like you have an expressway, anybody who wants to go anytime, anywhere, they will just drive the car and the traffic becomes totally unorganized. So what I am trying to represent here is, these are the, it's not like that this is not efficient, but it's a very easy model where if you are not bothered about any constraint, or if you want to just try to prove your point, these are the techniques may help, but this is totally unorganized way of solving the problem. Now we will take example of other two models as well here. One way, out of that, one is ring all reduce, second one is tree all reduce. So if you look at here in ring all reduce, in this technique, what they assure is, GPU will communicate and receive from only another GPU, only one. So what significantly it will improvise compared to the last algorithm, your traffic or your burst or your unmanaged traffic will reduce a lot. Okay, earlier it was one to many or many to many. Now it becomes like a traditional, and you can predict this traffic. There it was totally, the moment you horizontally scale, it demands will increase. Here it is not like that. The second model, if you look at it, it is kind of bottoms up approach, where you have to visualize those nodes as in computing unit, but as in tree, where your gradients will pass on from bottoms to top, where when it reaches to the finally to the root level, that root node or root GPU will again broadcast it to the peers, to all of them. Now these are the optimized way of or training your large LLM models, but as I said, no matter which one we pick it up, optimization in execution, optimizing in or parallelizing all these jobs are necessary in order to make a good throughput out of any model. Okay, each and every one has its own way of solving the problem. You cannot compare just directly that this is better and this is not better, but of course when you look at that problem, for that problem which one works best, that is what people pick it up for their further evaluation and training their model. Now let us summarize what we have discussed here. Okay. Now for this one, if you look at our Gen AI network, and we call it as an AI fabric, right, what's the summary of it, what it needs actually? If you look at it, it had evolved, it now become a GPU centric, your topology has to change. Instead of typical 3-stage, 5-stage clause, it becomes like a dragonfly or probably fat tree sort of topology. So your deployment strategy is changing. Now your network has to be absolutely quick enough to support all this GPU computation, so that your throughput will increase and your training phases, your inferencing phases are quick enough in order to give you the results. Otherwise, if I ask the question and next day if I am getting the result, what's the use of it? Nobody will use it, right? Nobody is gonna having that much patience to wait for those results to come. Those days and that era is, I think, gone. That's why we are discussing this as a problem. Now other than that, some of the keywords which is written here, lossless network, right? Lossless network is not only the unique characteristic of this, but what we are trying to put here is point number 3 and 6 are interrelated. If you are losing something, okay, if that gradient is playing any pivot role in getting your actual end results out, or if you delay your further aggregating gradients out of the single gradient, right, it is gonna impact the end result ultimately. So 3 and 6 are kind of hand in hand, and both of them are interrelated. There are various aspects of it, which is you earlier we used to oversubscribe any topology or any deployment network, but right now if you try to do that, it is going to backfire on us. So these are the various summary, or you can say the unique characteristics our AI fabric carries compared to our traditional fabric. So that's what I am trying to showcase over here. Now moving on, let's try to address these answers using a SONiC. So my agenda today here is not to pick any specific solution saying that this is better, no, this does it better, but as a community we should first look at it, okay, this is the problem which we have it already, now how or what are the answers we have it already. So I think as a community we stand, I would say, above the par, okay, as per me. So when we try any customer use case and when we look at this as an AI, as an Gen AI as an deployment, or sorry, Gen AI as a problem, and when we come up with the very optimal topology which works for the customer, right, there are unique features provided in the SONiC, which you can see here, I just listed down few, but it is more often fine graining, fine tuning your deployment so that it will solve the customer use case. Okay. Second thing is more often change in way of how we are traditionally doing our routing. Okay, adaptive routing and cognitive routing are having some of the answers. We have seen in customer deployments that first when we look at any deployment as a problem, right, with the some fine tuning around this area, it solves probably 60% of their problems, and we get most of the answers by tweaking some of these parameters here. Now, not only the switch as a solution, always look at the multi-component solution. Some of the NIC are available in the market already. I think many people are here aware, and maybe more information, might be having a more information than. You can employ the smart NICs which has a more capabilities in order of reassembling and packet reordering, that sort of thing, which will eventually increase your throughput. So it's not only one thing has to solve all the problem. When you try to put all these ingredients together, you will have a definitely majority of the answers being answered. Having said that, not only that, okay, these are the things are solving the problem and we are good enough, we need not to do anything. There are many opportunities are still there within community SONiC, and there are few challenges as well as in community which we need to address it. So I'll take this slide, last slide here, where if you look at it from the SONiC perspective, right, SONiC provides many features as I covered up in the earlier slides through which we are solving Gen AI as a problem. Second thing is, I think maybe Amir only took it, that multi-vendor. SONiC, community SONiC is an answer for it. I am not going into the detail of it, but it gives a lot of flexibility as an end customer. You have your most of the problems are answered that you don't want to stick to one, you can have multiple things in your network. Which one is performing better in what use case, you can employ that and you will never stick to the one. You have a freedom, so ultimately customer is the king here. And SONiC is, what I am trying to represent here is, that is a plus for us, for all of us. Okay. Now, looking at the speed or the port speed, now those era has gone where we used to talk only 1 gig, 10 gig, 20 gig. I think already we know there are solutions available, switch is available with the community SONiC itself, which can support 800 gig, 400 gig port speed, right. So that is also answering few of AI Fabric's need. Now I'll not talk more about what it is offering, but if you look at the enhancement, right, there are, I think as a community or who all are present here, we are working towards, I think in the first presentation it was covered up, AI work groups are there, people are working, communities are contributing to each and every problems what we have. So anything, the new innovation or the slightly tweaking in terms of algorithm or the protocols, say for example ECMP. ECMP is not direct relevant when we look at AI Fabric, right. You might have, because of all these connecting techniques, there is not too much of randomization in place. So you might have to come up with the improvised ECMP, which is nothing but ECMP and port pinning sort of things, which can help you to get your better throughput. So yeah, there are challenges still with us as a community. Okay, I think community or we are working towards solving one after another one. All of us who are representing their own companies here, right, they are contributing directly or indirectly one or other way, solving some of the problems already. If you look at the past presentation given by various folks here, right, and even the opening speech, they represented how many features they are planning to commit. If you compare the last year's roadmap versus this year's roadmap, right, aggressive commitment, aggressive feature delivery, that shows as a community or SONiC community we are improvising and we are trying to solve a Fabric as a problem by SONiC itself. Now we all are contributing from our side, being selfish for ourselves, but that's all okay. Okay, but the good part here is everybody is contributing back and making a single thing as a single identity for all of us. Yeah, with that note, I just wanted to conclude my presentation here. Yep.